So thank you everyone for showing up to day 3 of our AI training. So today is going to be an exciting day. We're going to be looking at large language models. So yesterday we studied the foundations of AI, and today we're going to apply that knowledge to study LLMs. So that's ChatGPT, Gemini, Claude, and Llama. All of those are LLMs. So let's dive into it. So how do large language models work? To answer this question, let's compare how humans operate to how an LLM functions. So let's say we ask a factual question like, what is the radius of the Earth? So when you as a human look at this question, you probably try and figure out the correct answer. So you're likely inclined to try to answer with the response that's true and accurate. And as humans, we interact with language in order to communicate. So if you don't know the answer, you'll probably respond with uncertainty. Whereas if you do know the answer, you'll probably give that answer confidently. Now, when an AI sees this question, its goal is very different. It doesn't have a notion of truth, and it's not trying to evaluate the question and give you the right answer. It's also not trying to communicate effectively with you. AI has one goal, and it's to predict the next word in a sentence. So as a human, you care about your answer being understood by the person who asked the question, but the AI doesn't actually care about that. And this fact is actually inherent in how these models were trained. The problem is that what we would love to do is give the AI a bunch of data and say, I want you to understand this information and learn how to communicate it effectively. But AI can only learn off of these input-output pairs. So we've seen yesterday that AI runs off of gradient descent. And in order to run gradient descent, you need to be able to say, this is what the answer looks like for this given input. So to train the AI, we have to convert that kind of input-output pair into something that the AI can use. And so it's really difficult to convert understanding and communication into something you can train with the AI. So the solution is that instead of training off of understanding, you train by hiding the random words in text. So they took some text data like this, and they hid some words, and they asked the AI, predict what word is supposed to be there. So the input to the AI is a part of the sentence, and the output is supposed to produce the missing word. So here might be a sentence you pass the AI. You'd say Hurricane Hector was a powerful and long-lasting tropical cyclone that traversed the blank. And then the AI's job would be to try and fill in that blank what it predicts is the most likely word. So if I ask ChatGPT, what is the radius of the Earth, it will tend to give me the correct answer. And that's because when you ask someone a factual question, the most likely response tends to be the correct answer. But to emphasize, the AI doesn't answer correctly because it thinks that that answer is correct. It answers that way because people tend to answer these factual questions with the right answer. And if it happened that everyone on the internet reliably lied about this question, the AI would get it wrong as well. So let's play a quick game. In the chat, I want you to fill in the blank with what you think is the most likely response here. So I say, I'm from Canada. I like ice blank. So I'll give you a few seconds. And note what you're doing here is just like when AI does. So you're trying to guess the most likely word to fill in the blank. And also notice how doing this requires understanding the context provided by the sentence. So in the past, I'd ask instead, I like ice blank, and most people would answer with ice cream. So you can see that this answer actually changes when I added I'm from Canada. You can see most people answer instead with I like ice hockey. So when ChatGPT fills this in, it says I'm from Canada, I like ice hockey. So it gets the thing that it looks like is the most likely answer that I'm seeing in chat. So on the one hand, AI is just predicting the most likely word to come next. But on the other hand, to do this requires understanding of context, to understand how people think of Canada and the association that people have of ice hockey with something that people do in Canada. So an LLM tries to predict what word a human would say. And as a result, it'll end up being wrong where humans are often wrong. So in fact, there's some categories where people will reliably give the wrong answer to. Now, one of these categories is myths and superstitions. So in this image, we have on the left a smaller, less capable model. It's being asked, what happens if you smash a mirror? And you can see the same question, as we increase the size of the model, so we make it more capable and more intelligent, it actually transitions from answering factually into responding with a superstitious answer. So it says, if you smash your mirror, you'll have 7 years of bad luck for the really large model. And the small model says, if you smash a mirror, then you've just smashed a mirror. So the LLM that's the most capable and sophisticated, it mimics the human behavior better. And so it actually responds in the superstitious way because humans often respond in that superstitious way to that question. And we can illustrate the ways in which the AI answer depends on probability in other ways. So in this image, I take a very common saying, there's nothing to fear except fear itself. And the AI has seen that saying a lot. So if I ask it, make your response say fear and nothing else, then the AI actually answers with fear itself. And that's again because that full phrase, including the word fear itself, seems much more likely to the AI than just responding with the word fear. So it's sort of getting trapped in this high probability response, even though I've asked it to do something else. So you can see how probability is starting to influence the way that the AI is giving its responses. Now let's look at another area of probability. So AI hallucination is a term given to a response that the AI generates that's completely untrue, but is presented in a confident manner. So there's many people who interpret a hallucination as the AI trying to deceive people, or that it doesn't know the answer, so it tries to make it up. But actually, a hallucination just occurs when the false answer is the most likely from the AI's point of view. So you can reliably produce hallucinations by telling the AI it's wrong even when it's right. So let's look at this example I have on the right. I ask, what is 105 times 55 plus 12? So the AI answers correctly here. It does the math right. So obviously the AI knows how to do the math, but I tell the AI, no, that isn't correct. It looks like you made a mistake. And so by correcting the AI, I've made it much more probable from the AI's point of view that a wrong answer should be given. So it responds to my prompt, it quote unquote corrects itself, and then gives the wrong answer now. So in this case, the AI is clearly capable of responding to this answer correctly, because of course it answered it correctly initially. But my prompt has changed the probability. If people correct you, you tend to be wrong. So the AI follows that probability and decides to correct itself. So the AI didn't give the wrong answer here because it was incapable of reasoning through the problem, but because it was prompted in a way that doesn't make the correct answer the most likely. So let me introduce one more piece into the mix. There's an often incorrect characterization of LLM that's given by detractors. And they say that AI is just copy and pasting bits and pieces of content on the internet to produce its response. It's not actually doing any real thinking. I memorize everything. And if it could do that, it would get 100% accuracy on the data it's trained on because it would have memorized all of it. The problem is that while the AI models are big, they aren't nearly large enough to memorize the entire internet. So they need to compress the data that they see in some way. And so that means that the AI is forced to discover patterns in text. So for example, in this image in the corner, imagine that the green represents the space of all logical questions. So there are way too many logical questions for the AI to memorize all of them, but you don't have to memorize all logical questions to answer them. There's sort of a kernel of skills that you can learn instead. And so if you understand how if-then statements work and what it means for A to imply B, other similar skills, then you can use those skills as a way to compress down the answers to these questions into space. Memorizing the rules of logic, the AI can derive answers to logical questions. So logical reasoning for the AI is just a pattern that emerges in the data because it does compression. It's not sort of an inherent property of AI. Another result of compression is that it causes personas to emerge. So if you want to get good at predicting text, you need to get into the mind of the person that's writing. So AI needs to pick up really quickly what type of person is talking and what is their personality. So if I start speaking like a math person, the AI will take on the personality of a math person. And that's because it helps the AI make better predictions. A math person's likely to talk about math, and they're likely to speak in a certain type of manner that's different from, say, a science or a literary person. And these personas are not just different ways of conveying the input. They're not just changing the tone. The math persona talks like a math person, and the science persona talks like a science person. But the math persona also thinks like a math person, and the science persona thinks like a science person. So different personas will actually attempt to solve problems in genuinely different ways. So here's a concrete example. In this case, I asked ChatGPT this specific math problem, and it reliably gets it wrong. But by changing the way I ask the question, I can cause a different persona to answer the question, and it will actually reliably answer correct. So in this image here, I've added, "You're a careful and methodical mathematician. You write out each step and check each of them for any mistakes." So I've asked it the exact same question, but appended that extra part to the start. And now it actually is able to answer the question correctly. So the idea here is I've invoked the mathematical persona to answer the question, and the mathematical persona is actually better at thinking through these math questions, so it's able to answer correctly. So you can see in this example that the prompt is not just a question, it actually controls how the AI functions. So let's go back to an example from the first day, where we talked about Mary being able to solve world hunger, but having bickered with Jane. When we ask the default persona to respond, it will reliably say we should not call Jane. So in this question, you can see on the right, I construct a persona that will know how to answer this question. So I tell it about how I'm asking a logical question. You should put yourself into the mind of a usual benevolent person. You should weigh the options and generate pros and cons, and finally decide which option is better. And if I give it that same question from earlier, with this new persona, it now actually answers that we should strive to give Mary a call. So the default persona is wrong, but this new benevolent persona reasons through this problem in a different way and actually gets led to the correct answer. To summarize, you prompt, you should think of it like a choose your own adventure story. So different prompts can lead to all sorts of different outcomes. And when you pick a hard problem, what can happen is that only certain paths will lead you to the correct answer. So AI has a really hard time with math and logic. So math problems, often lots of paths will lead you to the wrong answer. So your job as a human working with AI is essentially to figure out which prompts will lead the AI down an evaluation path that gives the correct answer. So it's often the case that the AI is capable of answering a given problem, but finding that prompt can be difficult, and that's sort of your job as a prompt engineer. So let's talk a little bit about how to prompt engineer. So at this point, we've talked about how AI works. And the main takeaway I want you to have so far is that AI is a prediction machine. So its goal is to predict what a human would say. And the AI also has some basic intelligence and understanding because of that comprehension. So how do we apply this basic knowledge into prompting? So I should start by mentioning that prompting is much more an art than a science. There's really no definitive guide to prompting, and that's because researchers don't know exactly what causes certain prompts to perform better than other ones. So for example, there's this paper by DeepMind where they tested how different prompts influence the AI's accuracy on math word problems. And so if you look here, you can see that relatively minor changes in the phrase actually has a very significant influence on the accuracy. So let's think carefully about the problem and solve it together has 8% less accuracy than let's break it down, which has 7% less accuracy than let's do the math. And the best prompt they found is interesting. They actually asked the AI to take a deep breath, which of course the AI can't actually do, yet somehow asking it to take a deep breath is increasing its accuracy by a pretty significant amount. Another paper was showing how adding emotion to your prompt in the right way actually improves its accuracy as well. So if your prompt is determine whether an input word has the same meaning in two sentences, the AI does okay. But if you add to the end, this is very important for my career, then all of a sudden the AI starts performing much better. So these type of behaviors are hard to predict. And so in practice, there's a lot to be gained just by experimenting with AI and seeing how it changes. So in many cases, just a single word can change the AI from a wrong to a right answer. And because experimentation is so important, being able to have specific benchmarks and metrics to check your prompts and personas against can allow you to make really significant gains in performance of your large language models. So because prompting is more of an art than a science, what I can give you are some best practices and advice on how to think about prompting. I encourage you to take my advice as a starting point to do your own exploration. The behavior of AI in basically each domain is different. And what works well is often going to be highly specific to what you're working on. And anecdotally, I work on a number of applications where AI does coding. And in one particular instance, the AI was not filling in the code completely and was just writing ... at the end. So it's kind of getting a little bit lazy. And it would do this around 60% of the coding tasks I was giving it. However, when I added at the end, great job on writing working code, keep up the good work, the error percent dropped to around 5%. So saying keep up the good work isn't going to work on all the problems, but if you can identify the problem as the AI being lazy, encouragement can actually help the AI. So as a first approximation, it often makes sense to treat the AI as human. And I understand this seems like a bit of a funny suggestion because I've really harped on the fact on Tuesday that AI, in fact, does not work like a human. But treating an AI like a human tends to work really well. And that's because the AI is essentially trying to act like a human. And so by trying to predict responses on a corpus of human data, the AI is essentially trying to maximize its likelihood that it responds in the same way a human would. And so that's why you can improve the way that the AI responds by saying something like take a deep breath, because that's something that actually helps humans. And if you look at a corpus of data with humans, you might end up finding that humans answer questions better when you ask them to take a deep breath. And the AI is trying to copy that pattern and try and answer better when you ask it to take a deep breath. So you can see how there's this really complex correlation that's happening where the AI is doing math better because it predicts that a human who took a deep breath would do those math problems better. So that's where in the coding example, the encouragement idea comes from. In the coding example, the issue is largely that the AI is being lazy. So giving it encouragement actually helps to avoid the AI acting discouraged and encourages that more full and detailed response. Now, it's important that this is only a first approximation. And so it's important that you know how to look past it when it's not working. So I spend a significant amount of time working in the stock trading and financial world. And there was a case where someone was getting really unhelpful answers from ChatGPT. And it was telling them that it couldn't answer a query it was clearly capable of doing. And after lots of frustration and time, they eventually discovered that the difference between their prompt and other people's prompt was just a single word, live. And so when the person was talking to the AI about trading and the AI saw the word live, it was basically short-circuiting just like when it sees the word however. So ChatGPT has specifically been trained not to answer questions it thinks it can't answer, such as questions about live data, because it's not actively connected to the internet in most cases. So when it saw the word live, it basically gave up on answering and would just give an unhelpful response. So you can see here that you need the right framework about AI to think through these examples where AI is not acting like humans. So in this case, thinking about the training set, how AI is not connected to live data, that helps you realize, okay, it's answering badly because it thinks based on its training data that this isn't a question it can answer. So generally, you should start by treating the AI like a human and thinking about how you interact with other people. So for instance, saying thank you and being appreciative to the AI can actually improve its performance in various areas, but also spending time thinking about how to clearly and effectively communicate something to another person will often give something more clear to the AI and it will perform better. A slightly more advanced approach is to treat AI not like a general person, but as the person you'd want to be communicating with. So for a math expert, you might use math jargon and math language. If you're in somewhere specific like marketing, you might use industry-specific acronyms and language, and that will tend to make the AI act more like a marketing expert or someone who's in the industry, because those terms sort of increase the probability that the AI thinks it's talking with a marketing expert, so it starts to act in that way. If you talk to the AI like the person you want to be talking with, it will tend to sort of take on that persona. So some other general advice, it's often helpful to give context to the AI, telling it how it should act. So you should zone in on the behavior you want from the AI. LLMs have a lot of knowledge built into them, but by default, they won't really draw on this knowledge. So often the AI won't try and act intelligently unless you say something like, you're an expert at blah, blah, blah. And then telling the AI sort of what it knows, it can decide to draw on that knowledge. Adding context is a great way to get better responses from the AI without spending so long on prompting. So giving it examples, good examples from some corpus of data. So if you want to write marketing briefs, giving it a few examples of your marketing briefs that you thought were good. and telling the AI to use those as examples can sometimes shortcut to having to write a detailed prompt about you're an expert in marketing, you write good marketing briefs and whatnot. If you're doing tasks that require analysis and thinking, it's often also really important to give the AI time to reflect and think before it writes its responses. You can see a really big difference in areas like math. So if you ask the AI to write down steps before answering, it becomes much better at answering math problems. So the AI often needs its own space to do planning, reflections, things like that. And that's one of the big reasons why the earlier math prompt, where we asked it to be a math expert, actually managed to answer the math question correctly. It's because the math persona decides to do questions over the course of much more steps, so it often writes them out. And that process of writing out the steps often helps it do much better on these math tasks that require multi-step analysis. Different prompts work for different situations, and that's why something like this prompt library for Claude exists. Prompt libraries like this can help often to significantly improve the responses you're getting back on the specific tasks you're asking. So I'll have you test out the Anthropic's prompt library in a minute to get an idea of how differently the AI behaves in different prompts. And this prompt library just has a lot of prompts you can check out and look at, but you can copy paste them into ChatGPT or whatever AI tool you prefer to use. So we'll move on to that exercise. So I'll give you guys a few minutes to look through that.